Today we are going to discuss some important problems based upon the theory of numbers, but from the starting we will try to discuss some problems related to the basics of the rational and irrational numbers, along with the problem based upon the mathematical induction, and also some application of the linear equations. Now, this is very important to understand that such problems are very important and beneficial for the students. They are preparing for the mathematical competitions as well as for their school level syllabus. But the problems are very good, and I hope that if you will be interested to go through such problems, then it will definitely, the session and the workshop will help you to boost up your concept for the basics of mathematics. So now here we can see that we have total 6 problems to discuss. In the last workshop we have discussed the problems upon the geometry, and in the very first workshop we had a session based upon the algebra topic. So now here you can see the first problem is based upon the rational number. Here express the rational number whose decimal expansion is 0.12345454545. This is non-terminating decimal fraction as ratio of two integers. Also find all positive integers n for which square root of n minus 1 plus square root of n plus 1 is rational. In the second problem, for the part A, we have to prove that 5 to the power 2n minus 6n plus 8 is divisible by 9 for all positive integers n. The part B is let un is equal to 1 and u2 is equal to 1 and un plus 2 is equal to un plus 1 plus un for n is greater than equal to 1. Show that un is equal to 1 by square root of 5 into 1 plus square root of 5 by 2 power n minus of 1 minus square root of 5 by 2 power n for integers n greater than equal to 1. The third part is let a, b, c be integers. The equation ax plus by is equal to c has a solution if and only if ab divides c. Also if x naught y naught is a particular solution of ax plus by is equal to c, then a general solution is given by. We have to find the general solution. The fourth problem is find all integral solution for 93x minus 27y is equal to 6. The fifth problem is give a test as to the divisibility of a number by 7, 11 or 13. Also solve 17x congruent to 1 modulo 180. So this is the problem from number theory. The sixth problem is define and give the example of linear equations and the greatest common divisor. So these problems are very basics and also important for the further good problems and discussions on the workshop and session on number theory. So now we are starting our discussion. In the first problem, we can see that the expression like here can be used at let x is equal to 0.1234545455 and so on. Now we are just multiplying 1000 both the sides, because here we can see the decimal part is here, and after the third place when we will shift the decimal here, then 45454545 is the periodicity in the fractional part. So we have to multiply, we are just multiplying 10 to the power 3 both the sides, and we get the result as 10 to the power 3 into x is equal to 123.454545 and so on. Now again we are multiplying by 10 to the power 2 both the sides, then this will be like 10 to the power 5 x is equal to 12345.4545 and so on. Now here for these two equations, if we will subtracting both the equations, we get 10 to the power 5 x minus 10 to the power 3x is equal to 12222, and here you can see the decimal part is 0, so this will be an integer. And now if we are taking 10 to the power 5 minus 10 to the power 3 from x, this will be like 12222, and here like after subtracting 10 to the power 5x minus 10 to the power 3x is equal to, you can see the decimal part are same here, so the decimal part will be 0, and 1 2 3 4 5 minus 1 2 3 will be 1 2 2 2 2, so this will be an integer. And now we are taking x common, so 10 to the power 5x minus 10 to the power 3 into x is equal to 1 2 2 2 2, and here x is equal to 1 2 2 2 2 12,222 divided by 99000. Here you can see this is in the form of PYQ, and also here Q is greater than P, so this will be the proper fraction because P is greater than P is less than Q, the denominator is large, so this will be proper fraction. So we can see that here x is equal to like in this form is the required solution. Now the second part of the problem is also find all positive integers n for which square root of n minus 1 plus square root of n plus 1 is rational. So here we can simply see that the xn is equal to a square root of n minus 1 plus a square root of n plus 1 be rational. We are just assuming that the expression is rational, then this is clear that the reciprocal of this expression 1 by xn is also rational. But one thing is to be understand that 1 by xn is equal to 1 by square root of n minus 1 plus square root of n plus 1, and this is like you can see square root of n plus 1 minus square root of n minus 1 divided by square root of n minus 1 plus square root of n plus 1 into square root of n plus 1 minus square root of n minus 1. Now here what we can do, we can simply write this in the form square root of n plus 1 plus square root of n minus 1 divided by 2. So here it means that the value square root of n plus 1 minus square root of n minus 1 is also rational. So we can write square root of n minus 1 and the second term square root of n plus 1 are also rational, and that is n minus 1 and n plus 1 are the perfect square. Otherwise this may be irrational, so this will be completely the perfect square because of this reason. So the three parts are important here to understand. The first is this, the second, and the concluded result is n minus 1 and n plus 1 are the perfect squares. Now in the second problem we have to prove that 5 to the power 2n minus 6n plus 8 is divisible by 9 for all positive integers n. So we will try to solve this problem by using the concept of mathematical induction. And in induction the three principles are important. The first is this has to be true for n is equal to 1, and for the second case, if this is the function of n, then this must be true for fn plus 1 also, and finally for the given function fn. So now we have the value of fn is equal to 5 to the power 2n minus 6n plus 8. So for n is equal to 1, this will be 5 to the power 2 into 1 minus 6 into 1 plus 8, and this is equal to 5 to the power 2 minus 6 plus 8. This is equal to 27, and we can say that f1 is equal to 27 is divisible by 9. So f1 is true So the first case is true, f1. Now for the second case, for fn plus 1, this will be like 5 to the power 2 into n plus 1 minus 6 into n plus 1 plus 8, and this is like 5 to the power 2n into 5 to the power 2 minus 6 of n plus 1 plus 8. This is equal to 5 to the power 2 into 5 to the power 2n minus 6n plus 8 plus 144n minus 198, and this is equal to, we can say this is multiple of 9, so we can write this is as multiple of 9 plus here 9 into 16n minus 22. So here this is by the induction hypothesis. We are just mentioning this is by induction hypothesis. And finally, we can see that all the parts are the multiple of 9. So we can simply say that by the use of the principle of mathematical induction, 9 is the divisor of the given expression 5 to the power 2n minus 6n plus 8. So 9 is the divisor of 5 to the power 2n minus 6n plus 8, and this completely divides 5 to the power 2n minus 6n plus 8. Now the second part is here, that if we have the value of u1 is equal to 1, u2 is equal to 1, and un plus 2 is equal to un plus 1 plus un, then we have to show that un is equal to 1 by square root of 5 into 1 plus square root of 5 by 2 power n minus of 1 minus square root of 5 by 2 power n, and for integers n is greater than equal to 1, means we have to take n as the set of natural numbers. So now to solve this, first of all, for n is equal to 1 and 2, we have simply un is equal to 1 by square root of 5, 1 plus square root of 5 by 2 power n minus 1 minus square root of 5 by 2 power n, and this is equal to 1. And now assume that the result to be true for all integers k, such that k is greater than equal to 1 and less than equal to n. We are just checking and assuming the result, to be true for all k. Now for n is greater than equal to 2, we have un plus 1 is equal to un plus un minus 1, and this is equal to 1 by square root of 5, 1 plus square root of 5 by 2 power n minus of 1 minus square root of 5 by 2 power n plus 1 plus square root of 5 by 2 power n minus 1 minus of 1 minus square root of 5 by 2 power n minus 1. Close here. So this is for by the induction hypothesis. Now this will be equal to 1 by square root of 5, 1 plus square root of 5 by 2 power n minus 1 into 1 plus square root of 5 by 2 plus 1 minus of 1 minus square root of 5 by 2 power n minus 1 into 1 minus square root of 5 by 2 plus 1. Now this is simply equal to 1 by square root of 5, 1 plus square root of 5 by 2 power n minus 1, and this is 2 plus 1, so 3 plus root 5 by 2 minus of 1 minus root 5 by 2 power n minus 1 into 2 plus 1, 3 minus root 5 by 2. This is equal to 1 by square root of 5 into 1 plus square root of 5 by 2 का power n minus 1 into 1 plus square root of 5 by 2 to the power 2 minus of 1 minus square root of 5 by 2 power n minus 1 into 1 minus square root of 5 by 2 whole square, and this is equal to 1 by square root of 5 into 1 plus square root of 5 by 2 power n plus 1 minus 1 minus square root of 5 by 2 power n plus 1. So this is the result. Now here the third problem is, let ABC be integers, then the equation ax plus by is equal to c has a solution if and only if AB divides C. Also if x naught y naught is a particular solution of ax plus by is equal to c, then a general solution is given by. So now here this is linear equation in terms of x and y, and this is given that ABC be an integer. So first of all, this is the GCD of A and B we have to decide. So now let here AB is equal to D, and this is for like ax plus by is equal to c has a solution if and only if d divides c. And now suppose x naught y naught is a particular solution and also for x1 y1 is any other solution, then we can write simply ax1 plus by1 is equal to c, because we are assuming that x1 y1 is also a solution. So this will satisfy this equation ax plus by plus c. Ax plus by is equal to c, so ax1 plus by1 is equal to c. And now this is obviously equal to ax naught plus by naught, because x naught y naught is already a solution. This is particular solution, so this will also satisfy the equation ax plus by is equal to c. Now here a by d into x1 minus x naught is equal to b by d into y naught minus y1, and here we can write that a by d and b by d having the GCD equal to 1, and also b by d divides a by d into x1 minus x naught, and this will imply that b by d divides x1 minus x naught. So here there will be the existence of t belongs to integers, and such that we can write t into b by d is equal to x1 minus x naught, and this will also give a by d to t, and b by d is equal to b by d into y naught minus y1, or simply we can write t a by d is equal to y naught minus y1, and thus x1 is equal to x naught plus t b by d, and secondly here y1 is equal to y naught minus t a by d. So the two values, the first for x1 in terms of x naught, and the second y1 in terms of y naught, we have two values here, you can see, and this is also the important solution while you are discussing the greatest common divisor and the linear equations. So here I am highlighting the important points. The first is we are satisfying x1 y1 and x0 y0. Here I am writing satisfying So this is the solution. Also, the fourth problem is like find all integral solutions for 93x minus 27y is equal to 6. To solve this, first of all we have 93 and 27. So the GCD of 93 and 27 is equal to 3, and 3 divides 6. So therefore the here 93 27 having the greatest common divisor 3, and 3 divides 6. So now we can check the solution for x and y. So to find one particular solution, in first case, to find one particular solution, we have to apply the Euclidean algorithm to find A and B, such that here A 93 plus B 27 is equal to 3, and we have 93 is equal to 3 into 27 plus 12. So this is the first step of the algorithm we are applying here. I am writing, we are applying Euclidean algorithm. So here 27 is equal to 2 into 12 plus 3, and now 12 is equal to 4 into 3 plus 0. This is basically division algorithm, and we can write dividend is equal to divisor into quotient plus remainder. So now we have 3 is equal to 1 into 27 minus 2 into 12, and this is equal to 1 into 27 minus 2 into 1 into 93 minus 3 into 27, and this is basically equal to 7 into 27 minus 2 into 93, and this is, now we have minus 2 into 93 plus 7 into 27 is equal to 3, and so minus 4 into 93 plus 14 into 27 is equal to 6, and this is basically in fact minus 4 into 93 plus 14 into 27 is equal to 6, and this will imply minus 4 into 93 minus 14 into minus 27 is equal to 6, and now we have the values as x naught is equal to minus 4 and y naught is equal to minus 14, and this will constitute a particular solution. So The general solution can be given by, I am mentioning here, this is the particular solution. Now for the general solution we can write simply x is equal to minus 4 plus k into minus 27 by 3 and the second for y is equal to minus 14 minus k into 93 by 3 and by simplifying we can write the value of x is equal to minus 4 minus 9k and y is equal to minus 14 minus 31k. So now we will try to arrange the table for different solution as like here the value k and this is for x and y, and now putting the value k 0 1 and minus 1 and we are getting the result at minus 4 minus 13 5 minus 14 minus 45 and 17 and so on. We will continue the putting the value of k and corresponding the values for x and y we will get. So this is the final solution. Now we have the problem number 5. Give a test as to the divisibility of a number by 7, 11 or 13. So we have to give the divisibility test for 7, 11 and 13. For this we can simply, this is problem number 5. Now let n belongs to positive integer and this is already we have as n is equal to a naught plus a1 1000 plus a2 1000 to the power 2 plus dot 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 plus ak 1000 to the power k, and this is for simply ai is greater than equal to 0 and less than equal to 1000, and also I belongs to 0 1 2 up to k. So we note that 1000 can be written as simply like if we use 1000 and adding 1, so this is 1001, and now by the prime factorization method we can write this in the form simply 7 into 11 into 13, and now 1000 is congruent to minus 1 mod 7. We are using a is congruent to b, mod n means n divides a minus b or n divides a gives remainder b. So simply 1000 congruent to minus 1 modulo 7. Now 1000 is congruent to minus 1 mod 11, and also 1000 is congruent to minus 1 modulo 13. So this gives simply n is congruent to a0 plus a2 minus up to minus 1 to the power k and ak mod n for all n belongs to 7, 11 and 13. So here we are taking the values of n as 7, 11, 13 because this is given that 7, 11, 13 are the divisors of 1001. So we can simply write that 1000 is congruent to minus 1 because mod 7 means 7 divides 1000 plus 1 1001 and this is already given here. So now what we can do, we have simply 7, 11 and 13 divides n if a0 minus a1 plus a2 minus dot 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 plus minus 1 to the power k ak congruent to 0 mod n, and we have already the values of n. So the second case is this may be 0 for mod 11 and also 0 for mod 13 because we have 3 divisors here as 3 prime numbers 7, 11 and 13. For example, we can consider as you can see this is congruent to 0 mod 11 and mod 13 also. Now for example, we can consider n is equal to 1, 2, 7, 8, 4, 6, 5, 4, 1, 3. Then we have n is equal to 413 plus 465 1000 plus 278 1000 whole square plus 1 into 1000 power 3, and this is simply congruent to 413 minus 465 plus 278 minus 1, and this is mod 7. Now the same as 0 minus 3 plus 5 minus 1 relating to the result, this is congruent to 1 and mod 7. Likewise n is congruent to 413 minus 465 plus 278 and also minus 1. This is for mod 11, and now you can write this is congruent to 6 minus 3 plus 3 minus 1 is congruent to 5 mod 11. And now we can write the same for n is congruent to 413 minus 465 plus 278 minus 1 mod 13, and this is congruent to 10 minus 10 plus 5 minus 1 congruent to 4 mod 13. So this is the final result. We can simply see the important terms here. This application and for the result here, and also this important result to prove the divisibility for 7 and 11, 13 also. So this is the final conclusion, you can see. Now finally, the second part of the problem is also solve 17x congruent to 1 mod 180. So now for this we have to solve this for for 17x congruent to 1 mod 180. Now we observe that 180 can be written as 4 into 5 into 9. So we search the solution for the system for 17x congruent to 1 mod 4, the second 17x congruent to 1 mod 5, and also 17x congruent to 1 mod 9. Now 17x congruent to 1 mod 4 will imply that x is congruent to 1 mod 4, as 17 is congruent to 1 mod 4, because 4 will divide 17 minus 1 means 16, and we can write that 17 and 4 having GCD is equal to 1. So similarly, for 17x congruent to 1 mod 5 is equivalent to x is congruent to 3 modulo 5, and also 17x congruent to 1 modulo 9, and this is equivalent to like x is congruent to 8 mod 9, and the system will reduce like here you can see, if we conclude all the results, then x is congruent to 1 mod 4, x is congruent to 3 mod 5, and x is congruent to 8 modulo 9. So this is the important relation we have. Now here the important thing is like x is congruent to 1 mod 4 will imply x is equal to 4n plus 1, and this is for not for all n, some n belongs to integer. We have to check for what integers we can find the value of x here for 4n plus 1, and now 4n plus 1 is equal to x, and this will be congruent to 3 modulo 5, and here this will imply 4n plus this will congruent to 2 mod 5, and also this will imply 4n congruent to 12 modulo 5, or n congruent to 3 modulo 5. So this will imply the total like x is equal to x is equal to 4 times here n plus 1. So this is 4 times 5m plus 3 and plus 1. This is equal to 20m plus 12, 4 into 3 12 plus 1 13. So this is 13, and this will be for sum m belongs to integer. So finally we have the relation for 20m plus 13 is equal to x congruent to 8 mod 9, and this will imply the value 20m is congruent to 5, which is negative, and mod 9, and finally x is equal to 20 into 9k plus 2 plus 13, and this is equal to 180k plus 53 for k belongs to integer, and this is the final required solution we have for x. This is the final result. I am just highlighting the important points here. The first, we have factorized 130 in the form of 4 into 5 into 9. We have factorized, and here for the divisibility at 4, 5 and 9, we have the result as 17x congruent to 1 mod 4, the second 17x congruent to 1 mod 5 for 4, 5 and 9, and 17x congruent to 1 mod 9, and finally we have the second last result was there as 20m plus 13 is equal to x congruent to 8 mod 9, and after that we have concluded this is the important relation for x, and we have applied here to find or identify the value of x is equal to 4 times 5m plus 3 plus 1, and now this is the final result we have. Now the problem number 6 is like here you can see we have to define and give the example of linear equations and the greatest common divisor. So in the next session I will try to discuss this important part, but for this workshop session I have done the discussion of total 5 problems, and I hope the viewers can use this concept to build up their approach of solving problems related to number theory. So this is okay for now. Here for this last problem, number 6, we have to define and give the examples of the linear equation and GCD. So for this we are just so here we can start this by writing the division algorithm, which is called Euclidean algorithm, like here A is equal to Q1B plus R1 and B is equal to Q1 R1 plus R2. For this we have R1 is equal to A minus Q1B, for R2 is equal to B minus Q2 R1, and now this is equal to B minus Q2 into A minus Q1B, and we can write this as minus Q2A plus 1 plus Q1 Q2 into B, and this is R1 is equal to Q3 R2 plus R3, and here R3 is equal to R1 minus Q3 R2, and this is now equal to, we can write as A minus Q1B minus Q3 into minus Q2A plus 1 plus Q1 Q2 into B, as you can see here. So now this is basically equal to 1 plus Q2 Q3 into A minus Q1 plus Q3 plus Q1 Q2 Q3 into B. So this is the expansion of Euclidean algorithm for the remainder, quotient, dividend and divisor. So here one thing is important to note, that the latest remainder is equal to some multiple of A plus some multiple of B. This is the important remarks, and now eventually we got down the last non-zero remainder, which we will know that this is equal to the greatest common divisor of A and B. this is already we have done, like the last remainder if 0, then the last term before R3 will be the greatest common divisor of A and B. So this gives the desired solution to the equation for GCD of A and B is equal to AX plus BY. Now we have many examples for this, but here we are trying to forming the table as here you can see, like this is for A is equal to 5 into B plus, we are taking some example 718, and B is equal to 3 into 718 plus 193. Here 718 is equal to A minus 5B, and 193 is equal to B minus 3 into 718, and this is equal to B minus 3 into A minus 5B. This is equal to minus 3A plus 16B. Now 718 is equal to 3 into 193 plus 139, and here 139 is equal to 718 minus 3 into 193, and this is equal to A minus 5 times B minus 3 into minus 3A plus 16B. This is equal to 10A minus 53B. Now for 193 we can write this as 1 into 139 plus 54, and here this is 54 is equal to 193 minus 139, and this is equal to minus 3A plus 16B, also minus of 10A minus 53B. This is for again we can write this finally minus 13A minus 10A minus 3A minus 13A plus 69B plus 69B. Now again this will be continue until the form last term, which is in the form of remainder, will not 0. So we will have to continue this process again for obviously 54. So 54 is equal to 1 into 31 plus 23. Now 31 is equal to 130, 31 is equal to 54 minus 31. So 54 is equal to 1 into 31 plus 23, and 23 must be equal to 54 minus 31. So this is equal to minus 49A plus 260B. Again for 31 this is like 1 into 23 plus 8, and 8 is equal to 31 minus 23, and this is for 36A minus 191B minus 49A plus 260B, and this is finally equal to For 31, this is equal to 36a and 36a minus of minus 49. So minus of minus plus 49 plus 36 will be 85a minus 451b, and again for 23 this is equal to 2 into 8 plus 7, and now 7 is equal to 23 minus 2 into 8, and this is equal to, this is like minus 49a plus 260b minus 2 into 85a minus 451b. Again for 23 we can write finally 23 is equal to 2 into 8 plus 7, and now for 8 is equal to 1 into 7 plus 1, and this is 1 is equal to 8 minus 7. This is equal to 85a minus 451b minus of minus 219a plus 1162b. This is finally plus 219 plus 85, this is 304a minus 1613b, and finally for 7, here you can see 7 is equal to 7 into 1 plus 0. So this is the remainder here, 0. So 1 is the final GCD of this. Now we are just concluding the points as we have done this example and use the value as ax1 plus by1 is equal to 1 and ax2 plus by2 is equal to 1, and we are going to multiply the first equation by y2, multiplying first equation by y2 and multiply the second equation and second by y1, then we have the terms as x1 y1 and ax2 y1 is equal to y2 minus y1, and similarly if we multiply the first equation by x2 and the second equation by x1, and then subtract, we got b x2y1 minus b x1y2 is equal to x2 minus x1. So if we let the value k is equal to x2y1 and minus x1y2, then we can find the value x2 as x1 plus kb, and the value y2 is equal to y1 minus ka. So this is the values for x and y. So here we can see if the GCD of a and b is greater than 1, then in this case, to make the formula, we can use like if G is the GCD of a and b. So we know the Euclidean algorithm method that there is at least one solution for x1 y1 to the equation of ax plus by is equal to c. So in this case we can simply write that if G divides both, if G divides both A and B, so that x1 y1 is a solution of equation, this is a by gx plus b by gy is equal to 1, and in this case we can now our earlier work will apply. So we know that every other solution can be obtained by subtracting values for k, and the formula can be written as x1 plus k into b by g, and same y1 minus k into a by g. So this is the value we can use, which is resulted. So here one thing, likewise we have multiplied the first equation by y2 and second by y1, and similarly we have applied the multiplication, the first equation by x2. Here similarly the first by x2 and the second equation by x1, second by x1. So this is also very important to note. So this is the final conclusion, and we have done all the 6 problems related to the number system and number theory. Here are the total 6 problems we have done.